Hi, my name is Oktay. Welcome to today's video about the giant planet Saturn and its moons. The biggest moon is Titan. This is a nice Hubble image of the big planet Saturn. It is located at a distance of 10 AU from the Sun. 1 AU is a Sun distance of 150 million kilometers. And you can see the bands of the planet Saturn and its rings, this structure. At the right, that's a moon Mimas, and at the bottom, that's a tiny moon Enceladus. This is a picture of the NICE model. It explains the formation of the solar system. In these pictures, the circles are the orbits of the 4 giant planets: Jupiter in green, Saturn orange, Neptune dark blue, and Uranus light blue. At the left, that's the situation prior to the 2-to-1 Jupiter-Saturn resonance. In the middle, it shows the orbital shift of Neptune. Neptune, according to this model, was between Saturn and Uranus, and there was one event that caused the orbital shift of Neptune and pushed it out of its former location to the outer solar system. And at the right, that's the situation after ejection of the planetesimals. Today, there's a near 5-to-2 resonance of Jupiter and Saturn. So in 60 years, Jupiter completes 5 orbits, and Saturn completes 2 orbits. This is the artist's impression of how the solar system looked like at the beginning of its existence, 4.6 billion years ago. Giant planets were formed quickly within a few million years. For the formation of Earth took about 50 million years. You can see the circumstellar disk. And this is what happened. The new giant planet Jupiter interacted with the disk in the solar system and was on its way to the inner solar system. It is because of Jupiter that the planet Mars could not gain mass, because the planetoids that could have crashed into Mars were deflected by Jupiter. But then the situation was reversed because Jupiter got into a resonance situation with Saturn, and Saturn pulled Jupiter out of the inner solar system. And in this process, the planet Neptune was pushed over the orbit of Uranus out to the outer solar system where it is today. So Saturn is an essential planet for the existence of Earth and for existence of life. This NICE model has another variant with a planet 9 with about a mass of 5 to 10 Earth masses. It could be that during this outward migration, the planet 9 was ejected out of the solar system. Or it could be that it was pushed out far beyond the orbit of Pluto, and planet 9 can be still a member of this solar system. This infrared image of Hubble of the planet Saturn. Its mass is 95 Earth masses. Main components are the same as the Sun: 96% hydrogen, 3% helium, methane and ammonia. Saturn has the lowest density of all planets with just 0.69 grams per cubic centimeter. Its equatorial diameter is 120,000 kilometers. It's flattened at the poles by almost 10%. That's because of its fast rotation period at 10.5 hours. Orbital period is 29.5 years. And its orbital speed is 9.7 kilometers per second, which is very impressive. This is another Hubble picture of the planet Saturn. Its axial tilt is 27 degrees, so we see the planet from different angles from Earth, because the orbital speeds are different of Earth and Saturn. The rings extend from 6,600 to 120,700 kilometers. They have a thickness of 10 meters to 1 kilometer, and their origin is unclear. there are certain times where we can see the rings edge on. That's when they disappear. This is a structure of the Saturn rings. This is a picture from the Cassini spacecraft. The rings are confined by the shepherd moons Pandora and Prometheus. They were discovered by Galileo Galilei in 1610 with a self-made telescope. He used tin organ pipes to build his telescope. This is a close-up picture of the rings. This is the Santos-Dumont structure, a ring propeller in the A ring, and it is caused by a moonlet, which is a minor moon. In this picture, you can see dark spokes in the B ring. This is again images from the spacecraft Cassini, and it could be that these spokes were caused by Saturn's magnetic field. This is an artist's impression of how Saturn will look in a few 100 million years. The inner rings will fade, and you can see something, another very interesting thing, that's Hexagon on the northern pole. This is a close-up picture of Saturn's north polar region, again from the spacecraft Cassini. It shows you the hexagon with its rounded edges. And the picture at the left, that's how it looked like in the year 2013 when it was blue. In 2017, however, it was covered in yellow haze. The yellow haze is photochemical smog particles. And the center of the hexagon is not covered, and the reason is unknown. This is a close-up picture from Cassini of Saturn's hexagon, and its formation is not clear. This is a global storm in white, northern hemisphere on Saturn. It has this structure because it overtakes itself. On Saturn, there are no mountains that could slow down the winds, so that's why how this structure was generated. This is another image from the Cassini spacecraft. This is the internal structure of Saturn and its features. There's a gas layer, and there's liquid nitrogen, heliums. Then there's a layer of metallic hydrogen, ices, and a rocky core. There's a Cassini division in the rings, which is 4,800 kilometers wide, and it is caused by the moon Mimas. This is a diagram of the moons of the 4 giant planets. The y-axis is the number of moons, and the x-axis is year of discovery. And you can see Saturn in yellow, Jupiter is red, light blue is Uranus, and dark blue is Neptune. For many years, Saturn had the most moons, until it was recently overtaken by Jupiter. Now, Jupiter has 92 moons and Saturn 83. The first 4 moons were discovered in 1610 by Galileo Galilei. These were the 4 Galilean satellites of Jupiter. And these moons are very important scientifically because they ended the model of the geocentric universe. These were the first objects that it was clear they orbit Jupiter and not Earth. This is the biggest moon of Saturn. It's the moon Titan. It's at a distance of 1.2 million kilometers and has a size of 5,150 kilometers. It is bigger than Mercury. Its orbital period is 16 days. Titan has a dense atmosphere with nitrogen as main component, but it also contains hydrogen, methane and ethane, and solins. Solins are products of hydrocarbons with nitrogen and UV light. This is a picture of the surface of Titan. The Huygens probe landed in 2005 on Titan. And you can see in the background this dark material, this potentially this solin compounds. And another very interesting thing is in the foreground is rounded rocks. So the erosion on Titan is quite strong because you have rain of hydrocarbons, methane and ethane. And Titan could have a potential subsurface ocean, potentially with life. This is a picture of the north polar region of Titan. You can see in dark blue these methane and ethane lakes. Titan has a circulation of methane and ethane, just like the circulation of water on Earth. One big difference is surface temperature on Titan is minus 180 degrees Celsius. This is another very interesting moon of Saturn. That's the tiny moon Pan. Its size is 35 kilometers by 23 kilometers. Its orbital period is 14 hours. And you can see it has a ravioli shape. Because this is a tiny moon, there's not enough matter to make a spherical structure. There's not enough gravity. And that's why it has this ravioli shape. Pan was discovered by Mark R. Showalter in 1990. It is a shepherd moon and it causes the anchor gap in the rings of Saturn. This is the moon Mimas. Its size is 396 kilometers, orbital period 22.5 hours. Mimas was discovered in 1789 by William Herschel. The biggest crater, Herschel crater, is named after him. It has a size of 139 kilometers. And Mimas could also have a potential subsurface ocean, potentially with life. This is the interior structure of another moon, that's Enceladus, with a size of 504 kilometers. Its orbital period is 33 hours. There are tiger stripes on this southern hemisphere. These are geysers. They emit ice particles. And you can see there could be a global ocean under the ice crust due to the tidal heating by Saturn and other moons by their gravitation. And Enceladus is a potentially candidate for life. You have all four requirements for life. You have liquid water. You have the basic components like methane, ammonia, carbon dioxide. You have energy source, that's the tidal heating. And you have the minerals. There's another moon of Saturn, that's Tethys. Its size is 1060 kilometers, orbital period 45 hours. And this is one of several moons that were discovered by Giovanni Domenico Cassini in 1684. That's why the spacecraft was given the name Cassini. And you can see a big 450 kilometer impact structure. This is called Odysseus. This is the moon Dione. Its diameter is 1,122 kilometers, orbital period 2.7 days. It has many big craters that are bigger than 35 kilometers. The impacts that cause these craters are strong enough to spin this tidally locked moon. And you can see at the bottom tectonic features. This is the moon Rhea. Its diameter is 1,528 kilometers. It's the second biggest moon of Saturn. The orbital period is 4.5 days. It's heavily cratered. And it has a very thin oxygen and carbon dioxide atmosphere. The origin of the carbon dioxide is unclear. There's another moon, Iapetus, diameter 1,469 kilometers, orbital period 79 days. It has two different hemispheres, a leading dark hemisphere and a trailing bright hemisphere. And there's a 20-kilometer high equatorial ancient ridge. Its origin is unknown. This ridge gives this moon a bit a structure like a walnut. This is the moon Phoebe. Its size is 213 kilometers, orbital period 1.5 years. It has a retrograde orbit like Triton. Triton is the moon of Neptune. Phoebe could be captured Kuiperbelt objects. And this moon is the source of the large Phoebe ring. This is an artist's impression of the Phoebe ring. It was discovered by the Spitzer Space Telescope. This is a nice image from the spacecraft Cassini of Earth, seen from Saturn. You can see here this tiny pale blue dot is Earth at a distance of 1.4 billion kilometers. This is an artist's impression of Saturn and its system of moons. And this is a Hubble movie of a quadruple Saturn moon transit. At the left, that's the moon Enceladus. Then you have the moon Dione. At the top, that's the big moon Titan with its shadow. And at the right, that's the moon Mimas. That was today's video about the giant planet Saturn and its moon Titan. Thank you for watching. Have a nice day. Bye bye.